Good evening, everyone. I am Sachin Kumar Malvi. So we have a subject called Introduction to Drones. In this following subject, we have a topic named communication between the various components in system. In this following topic, we will discuss about how the different components of the drone are used to communicate with each other. So let's start with the introduction part. So the drones utilize components like flight controllers, GPS, communication modules, sensors, and actuators. Efficient communication between these parts is crucial for coordination, data exchange, and autonomous operation, ensuring system integrity and real-time feedback. Then we will move to the components of a drone system. The components of drone system include flight control. Uh, in flight control, the drone's central processing unit. It interprets data from sensors and execute commands to control flight, maintaining stability and responding to the user input. The next module is GPS module. GPS modules provide precise location data, enabling the drone to navigate accurately, follow defined paths, and maintain its position. Communication module. In communication module, we have two submodules that are RF and Wi-Fi. RF stands for radio frequency. It facilitates long distance communication between the drone and ground control, essential for remote operation and telemetry. The next one is Wi-Fi. It allows for high speed data transfer, including real time video streaming between the drones and user devices. The next one is sensor. Uh, in this part also we have two submodules that are camera and radar. The camera captures images and video for navigation, surveillance, and monitoring, helping the drone to avoid obstacle and gather visual information. Lidar uses laser pulses to measure distance, creating detailed 3D maps of the environment and aiding in the navigation and obstacle detection. The last one is actuators. And this also we have two submodules that are motors and servos. The motor generates thrust to the control to drone's movement and altitude, enabling stable flight and maneuverability. Maneuverability. The next one is servos. It adjusts mechanical components such as camera, gimbals for precise control of movement and stabilization. The next part is communication methods. It is the communication. These are the communication methods that are used by the drones to communicate with different components that are inter-component communication and wired communication. So in wired communication, we have UART, I2C, and SPI. The UART stands for Universal Asynchronous Receiver Transmitter. The serial data exchange method for sending and receiving data between components. The second one is I2C. It's stand for Inter-Integrate System or Circuit. It facilitates communication between multiple components using just two wire simplifying connection. The next one is SPI. The full form of SPI is Serial Peripheral Interface. It enables high-speed communication protocol for fast data transfer between components. The second communication method is wireless communication. In wireless communication, we have RF, Wi-Fi, and Bluetooth. RF stands for radio frequency, long range communication method for remote control and telemetry. Wi-Fi provides high-speed data transfer and real-time streaming. Bluetooth is short-range communication for tasks such as pairing and transferring small amount of data. The other communication protocols are Mavlink protocol and TronCan. In Mavlink protocol, a lightweight messaging protocol used for sending telemetry data and receiving commands between drones and ground control station. A standard in TronCan, a standardized protocol that facilitates communication between UAV components such as sensor and flight controllers, ensuring consistent and efficient data exchange. This is the code for exchanging the communication between the component. This code is in Arduino. Uh, so the first line of code define the function void, and the second line of code, that is serial.begin 9600. Basically, it initializes the serial communication at a bound rate of 9600 bits per second. This sets up the serial port for sending and receiving data. The next one is void loop. In void loop, we have a condition if serial dot available. Basically, it check if there is any data available to read from the serial part. The serial dot available function returns the number of bytes available. The next code is care data is equals to serial dot read. Reads one byte of data from the serial buffer and stores it in the data variable. So serial dot print dot data, it can print the data that we are receiving in the following variable. This is the Python code for sending or receiving data from the Wi-Fi. The challenges and reliability we can consider in the components of drone include latency and reliability. It minimizing communication delay and ensuring data accuracy are crucial for real-time operation and precise control. Bandwidth constraints. A limited bandwidth can affect data quality, particularly with high-resolution sensors or streaming. Interference issue. External signals can disrupt communication. Techniques like frequency hopping and error corruption have mitigated this. At last, we will discuss the conclusion or summary. Effective communication is a vital for operation and success of a drone system. Understanding both the components involved and the communication methods used is to key designing drones that are efficient and reliable. This includes ensuring that data is transmitted accurately and promptly, which directly impact the drone's performance and ability to execute tasks. The future trends in drones component is such as emerging technologies like 5G and advancement in communication protocols are set to significantly enhance drone capabilities. This innovation will support more complex and demanding missions by providing faster, more reliable data transfer, and improving overall system performance. As these technologies evolve, they will enable drones to undertake more sophisticated operations and adapt to the new challenges with greater efficiency. Thank you.